Hello mathematicians, thank you for joining me today as we work through and we try to solve the system of linear equations given on the board here. As we try to solve this, there are many ways to solve systems of linear equations, including substitution, graphing, elimination by addition, but today what we're going to use is we're going to use augmented matrices. So we're going to have to set up our augmented matrix and then we're going to have to row reduce it so that we can finally get out our answer. Now, as part of that, the first thing I want to do is say, well, what would my augmented matrix look like? Is the idea is that I'm going to take the coefficients in front of the variables off, write those down in each of the columns, and then I'll end up with a column for each of the variables plus a column for the constants on the right hand side. So if I do that, as I read off the first row, notice I have x1 minus 3x3 equals negative 2. So what we notice here is that we want to make the first column the x1 column, and so we can even put an x1 there to keep that in mind. And so notice the coefficient in front of x1, despite the fact it isn't lined up here, we do want to line it up down here, so our coefficient is 1. Because there is no x2 written, that means the coefficient in front of x2 is 0. So the entry in my first row, second column is going to be 0. The coefficient in front of x3 is negative 3, and the constant is negative 2. And so I'll have the first row. If I continue with the second row, I'll notice that the coefficient in front of x1 is 3, and then the coefficient in front of x2 is 1, in front of x3 is negative 2, and the constant is 5. And then for the last equation, I'll have 2 x1s, 2 x2s, 1 x3, and our constant will be 4. And so now I've set up my augmented matrix, which again I'll have to row reduce in order to get out my solution. Alright, before we actually row reduce our matrix, we want to know what row reductions are allowed or what row operations are allowed. And so the idea is that if we start with this matrix, we want to convert it into an equivalent matrix, which means that if we wrote down the system of equations it represents, that would be equivalent to our original system of equations. And so what we saw were that there are 3 things we are allowed to do to end up with an equivalent matrix. Those 3 things were, I could multiply a row by a non-zero constant and replace that row. So the idea is I could take row 1 and multiply by 5, and then replace row 1 with that given number. So instead of 1, 0, negative 3, negative 2, I'd have 5, 0, negative 15, negative 10. Now, whether or not I want to do that here isn't the point. The point is that I would end up with an equivalent system of equations when I wrote down the equations equivalent to the matrix. And so I'm going to denote that as a constant times r sub I. I'm going to plug that into r sub I, where r sub I is just the row in the ith row. And so I'm going to replace the ith row with the ith row times a constant. The next thing I can do is I can multiply any row by a constant and then add it to another row. So I can multiply the first row by 1 and add it to the second row and replace the second row with that answer, and I would get 4, 1, negative 5, 3. So when I'm doing that, I'm going to say a constant times r sub I plus r sub j, and then I'm going to plug that into r sub j. And so that's how we're going to note that row operation. And the last thing I can do is I can switch rows. So that is, instead of having this be the first and this be the second row, I can call this the first and this the second row, so I can switch the order. And I'm going to denote that by r sub I goes to r sub j goes to r sub I, so I'm interchanging those 2 rows. So now as we row reduce this, those are the 3 things we are able to do. We want to keep those in mind and only do one of those 3 things at a time. Alright, so now as motivation for us as we go through and do our row operations, remember, what we want to do is we want to reduce it into something that is equivalent to a system of equations which is easy to solve. Ideally what we'd like to have is something that looks like 1, 0, 0, 0, 1, 0, 0, 0, 1, and then the squigglies over here just represent, I don't care what that is, it can be anything at once. The important part here is that I want this to look like this. If that does look like that, what this is saying as a system of equations is x1 is equal to whatever's over here, x2 is equal to this, x3 is equal to this, so that is a simple equations to solve. So if we can get this into this, we've done the work. So now with that in mind, the goal is that, okay, well, let's make this look like this, and so we're going to start to use our row operations to turn this into this. So now that I know what I want my matrix to look like when I'm done row reducing, I'm going to go through, and for my process, I'm going to follow the similar process each time so that I know that this will always work. While there are other options along the way, different row operations we can use, what I want to do is I want to start in the upper left-hand corner. I want to make the leftmost non-zero number a 1, then everything else in that column a 0. Then I want to move on to the second row, make the leftmost non-zero number a 1, and everything else in that column a 0. And then I'll move on to the third row, and I'll work my way through until I'm done with all the rows so that each of the leftmost non-zero numbers are 1. And then if I have to at the end, I'll switch rows so that I end up in row reduced echelon form. So with that in mind, I want to point out where I'm going to start is row 1, column 1 is right there. And so what I want is I want that to be a 1. Now, since that's already a 1, I don't actually have to do anything here, which is really nice. But if that was something else like a 2 or a 3, what I would do is multiply this row by 1 over that number so that I would end up getting a 1 here. So if it was a 2, I'd multiply the first row by 1/2. But since it's a 1, and multiplying by 1 over 1 is 1, doesn't change anything. So then we can move on and say, well, now we need these two entries to be 0. So I need the other entries in that column to be 0. So I want to turn the 3 into a 0 and the 2 into a 0. So how am I going to do that is, if you remember my multiply by a constant rule is that I have to multiply by a non-zero constant. So I can't just multiply this row by 0 and be done, because that's going to change the system of equations. Instead, what I have to do is I actually have to take something times the first row and add it to the second row to get rid of this 3. So I'm going to actually take -3, so the negative of this number, times row 1, or the row where I have the leading 1. I'm going to add that to my row 2, which is the row I'm interested in, and I'm going to plug that into row 2. Now at the same time, I can also change the third row, and the idea here is I want to turn a 2 into a 0, so I'm going to do the same processes. Well, instead of 2, I'm going to have -2. Row 1 is where I have my leading 1. I'm going to add that to row 3, and then I'm going to plug that in for row 3 in my new matrix. So now what my new matrix, or equivalent matrix, is going to look like is the first row stays the same. For the second row, I'm going to take -3 times the first row plus the second row. So -3 times 1 plus 3 is 0. -3 times 0 plus 1 is 1. And now, if it gets any more complicated than that, I'll write -3 times -3 is +9. +9 plus -2 is 7. So my next entry is going to be a 7. Now for the last column, I'm going to have -2 times -3 is 6. 6 plus 5 is 11. So the entry in the last column in the second row is going to be 11. Now that we've finished that row, we want to move on and change our third row. So now we're going to take -2 times 1 plus 2 is 0. -2 times 0 plus 2 is 2. And now -2 times -3 is going to be 6. 6 plus 1 is 7. So we have a 7 there. And then as the last one, I'm going to have -2 times -2, which is 4, plus 4 is 8. So my third row, fourth column is going to be 8. And so now I have the new row equivalent matrix given by this here. Now that I've row reduced my original matrix into this one, I'm going to continue to row reduce this matrix. And so what we're going to look at here is that notice that we already have the leading term in the first row 1, everything else in the column is 0. So now we're going to move on to the second row, and I want the leading non-zero term. So that one's 0, so I keep moving in here. I have a leading non-zero term. I want it to be a 1. Since it is a 1, then I don't have to do anything to this row, so I would leave it as is. But what I want to do next is I want to turn everything else in that row into a 0. So how am I going to do that is notice that this is already a 0, so it's working out pretty nicely here that I already have a couple of things done. But this one is a 2, so I do need to turn that 2 into a 0. So the thing we did last time was we took this number, the 2, and multiplied by -1, so -2, times the row with the leading 1 is the second row. And I add that to the row I'm trying to change, which is my row 3, and I'm going to plug that one into my row 3. So what I end up with is I'm going to take -2 row 2 plus row 3 and plug that into row 3, and I'm going to get my new matrix, which is, well, the first row rather stays the same, and the second row stays the same. And now for the third row, I'm going to take -2 times 0 plus 0 is just 0. -2 times 1 plus 2 is 0. And now if I take -2 times 7 is -14 plus 7 is -7. And then I'm going to take -2 times 11 is -22 plus 8. -22 plus 8 is -14. So we get a -14 here. And so now I have a leading term is 1 in the second row, and everything else in the second column where that leading 1 is now a 0. So now I'm ready to row reduce to the next. Alright, so now notice that I have a leading 1 in the first row and the second row. So I'm going to move on to the third row. I want to find my leading non-zero term. So here's 0, here's 0, here's a non-zero. So I want to turn that -7 into a +1. So in order to do that, what I'm going to do is I'm going to multiply this row by 1 over that leading term. And so I'm going to get -1 over 7 times row 3. And I'm going to substitute that in for row 3. So it is a non-zero constant times a row, plug it into that row, and we'll have an equivalent matrix. So if I do that, the first and second rows are going to stay the same. And now the third row is going to be -1/7 times 0 is 0. -1/7 times 0 is 0. -1/7 times -7 is +1. And -1/7 times -14 is +2. So now we've turned the leading non-zero number in the third row into a 1, so we want to turn everything else in that column into a 0. So we want to turn the 7 into a 0, and this -3 into a 0. So what I'm going to do is, what I have been doing is, take this number times -1 times this row, add it to this row so that I can cancel that out. And so what I get is -7 times row 3 plus row 2, plug that into row 2. At the same time, I want to get rid of the -3, so -3 is +3 times row 3 plus row 1. We'll plug that into row 1 so that we can then turn this into a 0. So now if we do that, what we end up with is our third row is going to stay the same. And now the first row is going to be 3 times 0 plus 1 is 1. 3 times 0 plus 0 is 0. 3 times 1 plus -3 is 0. And 3 times 2 is 6. Plus -2 is 4. So we end up with a 4 in the first row, fourth column. Next, we're going to have to work on the second row. So we get -7 times 0 plus 0 is 0. -7 times 0 plus 1 is 1. -7 times 1 is -7 plus 7 is 0. But then -7 times 2 is -14 plus 11 is -3. So we would get a -3 here. So notice now that we have completed row reducing this, we have the leading non-zero term in each row is a 1, and my 1s do work my way from left to right. So this is in row reduced echelon form. I have zeros in all of the columns with leading 1s. And so what I can do here is determine what the solution is going to be. The way I'm going to do that is, remember that this was the x1 column, the x2 column, and the x3 column. So for x1, I'm going to look for the leading 1. That corresponds to the first row. So the first row is going to tell me what x1 is. So x1 is going to be 4. Now if I look at the second column, the leading 1 is in the second row. Therefore the second row is going to give me x2. So x2 is -3. Same way with x3, the leading one is in the third row. So the third row is going to give me x3, so x3 is going to be 2. So what we have is that our original system of equations was equivalent to the system of equations x1 equals 4, x2 equals -3, and x3 equals 2. So therefore, the solution to the original system of equations is just x1 is 4, x2 is -3, and x3 is 2. Thank you for watching. As always, I hope you learned something today, and I hope you enjoyed the process along the way. If you did, make sure to like the video and subscribe to the channel. It helps me to know which videos are helpful, and it helps other people to find these videos so that they can also get help. Thank you.